We're going to show you what random is on a combination of random possibilities and how it reoccurs. Check it out, this dot right here. We want to show when it reoccurs, okay? We want to see it reoccur right next to it. We'll say if it's right next to it, it reoccurred. This is a possibility which is we're going to pick a dot. The corner, this dot right here. When will that reoccur? We want it to be right in it almost. Okay? So we're going to find out when that dot reoccurs. And we got a possibility of huge number, like the randomness of these numbers that are flashing. How many ever pixels there are in one circle per that whole segment of screen that's green. Okay, we got a dot near it. It almost reoccurred. Okay, this is how random. There's another one. Okay, we want it to be almost right on it. There's one. It's in the range. This is how random works. There's another one right on the other one there. Let's check it. There's three dots up there in the corner. The highest, most corner point, three angled / dots. Look at the dots reoccurring. Okay? We want to show that top dot in the corner, toward the corner. Randomness, even though it's a large combination of numbers, will reoccur eventually. This is a very large combination of screen pixels all over the entire screen of that, which is thousands. It's like 1030 by 1200. Okay, we're getting closer. So it's almost about 2 million, 1 to 2 million combinations of places that are occurring, and the random nature of them are how often they reoccur. There's a dot right by it. We want it to be right up on it. We want it to be offset just a little bit, because it will eventually reoccur if it hasn't already in the exact same spot. Not the cornermost, not the one below it at an angle, but the one above that at an angle. The third one from the most right corner. How long will it take? There it is. Almost right on it. Okay, took exactly 5 minutes. Okay, and that will eventually occur directly right on it. 5 minutes for 1,000,000 different combinations to reoccur. That's how random works with a computer. Okay, it may take longer to get that dot right on there, but this is just an example. Okay, so eventually that dot will reappear right over top of itself, and no, we won't actually know what the dot existed as unless we change the color of it. Okay, so we have to randomize the color also, but it may have already occurred. It looks like it did. Let's see. Yeah, it looks like it's slightly offset now on the exact dot that it is. So within 5 minutes, I'm pretty sure it could have reoccurred. But either way, it almost reoccurred. So if this was a chemical reaction of random nature, and that was just happened to be the random location of something, maybe. But see, geometry and the randomness of energy and time are a factor in any randomization of events. So this is just straight random numbering of location on a 2D graph. But in a three-dimensional polygeometric world, that would be a lot different. Okay, so it took 5 minutes for that to occur there, but you notice how many dots have collected in the region. Okay, so it is highly likely that eventually 1,000,000 places, 1,000,000 different random possibilities will eventually reoccur within a short enough measurable amount of time. So 1,000,000 places, which is all the pixel-sized dots that we're using here over this whole graphical screen. Okay, it's obvious that, see, it reoccurred there next to it. So I mean, it's not going to take very long to get the whole screen filled and then go over it again. So I mean, it's going to reoccur. It practically already did. So there you have it.